Okay, so in this video, we'll be discussing paper 1, Pure Mathematics 1 for May-June 2024. The variant is paper 1-2. Okay, so let's start with question number 1. They are talking about the coefficient of x squared in the expansion of this, and also it's 12 times the coefficient of x squared in the expansion of 2 plus ax power 5. Okay, so find the positive constant of a. Highlight the keyword positive. Okay, to find out or to expand any binomial bracket, right? So as an example, we are using the general formula where if you are having a plus b power n, the general formula for any particular term, right, it will be NCR, a power n minus r, then b power r. Okay, and for our question here, they are focusing on the coefficient of x squared, right? So if I try to apply the formula in my expansion here, with 1 minus 4x power 6, the general pattern will be 6c something, then 1 power 6 minus something, and after that, negative 4x power something. So we have to decide the something by ourselves, the power here by ourselves, okay? And this question focus on x squared. Therefore, to make sure that I get a square, I need to have a 2 here. Negative 4x squared, then later when you expand, you get the x squared here. So if this is a 2, then this is basically a 2. This is also basically the 2. So in short, you're having 6c2, 1 power 4, and then negative 4x power 2. Okay, so try to expand it and get the coefficient, which is 240. The whole term is 240x squared, right? Okay, then for the second bracket, I'm having 2 plus a x power 5. Same thing happened here. You're having 2 power n minus something, then ax power something. So again, what is the power for ax here? We focus on x squared. Therefore, I also want to have a square here. Then this power will be 5 minus 2, which is a 3. Then this is still a 2. Simplify this particular term, you will be having 80 a square x squared. Okay, then after that, they are talking about the coefficient. Coefficient of x squared in this bracket is 12 times the coefficient of x squared in the other bracket. Okay, so the coefficient for the first bracket here is 240 lah. 240 is the coefficient of x squared for the first bracket, and it is equals to 12 times. So you need to multiply with 12. 12 times the coefficient for the second, the x squared in the second bracket. So 12 times of 80a squared. Okay, then after that, you try to simplify your equation. For your final answer for the a should be equals to 1 over 2. We only consider the positive value because in the question, they did mention clearly that the answer for the a is a positive value. Okay, so this is how we solve. So question number 2, the curve y equals to x squared is transformed into this particular curve here. And they want us to describe fully a sequence of transformation that can be combined. Have been combined, making clear the order which the transformation have been applied. Okay, so how to change x squared become this particular equation here? Okay, there are a few ways that you can show it, yeah? So from x squared, maybe the very first step is you can try to change it become x minus 3 squared. After that, you multiply with 4 and then x minus 3 squared. Then only followed by y equals to 4x minus 3 squared minus 8. Okay, so if you want to have a look in details, the particular step, then it will be looking something like this. You try to minus 3 in the basic bracket first, basic function first, followed by multiply of 4 outside, then followed by minus the 8. So if you have a look and detail, right, this is actually translation in x. Okay, so from here to here is translation in x. From x minus 3 squared to this one is a stretch in y. And followed by the next one is the translation in y. Okay, so if you have a look for all the transformation involved in the steps here, right? there's only one translation in X, there's one transformation in X, but there are two transformation in Y. Therefore, the sequence of the transformation in Y is very important. You need to make sure that you are putting the sequence of Y correctly. Okay, so for the transformation of Y, basically we multiply something first followed by X. So that means you multiply, divide something first. You follow the normal mathematical operation. So multiply or divide come first, followed by plus or minus. Okay, so our sequence here is correct. Stretch in Y first, followed by translation. Okay, so you have to make sure that you need to have stretch in Y in front of translation in Y. And for the translation in Y and X, right, the X, it doesn't matter what, because X is only single transformation in the X direction. So no matter where you put it, it's okay, right? So we just need to confirm about the translation, sorry, the transformation in the Y lah, right? So if I want to write out for this case, my answer will be something like this, where first step, I want to make it as the stretch. So it is the stretch in Y direction or parallel to the Y-axis with the stretch factor 4. Okay, then after that, followed by translation in Y. But translation in Y and X, I can make it straight away into one transformation because the vector can fit in both directions for X and Y. So I just write translation with vector. Okay, so if you have a look for the X, it is minus 3. So when you bring it out from the bracket, it will be a positive 3. For translation in Y, it is negative 8. So you directly write negative 8 in your vector here. So we are combining the translation of X and Y in one step. So they can combine in one step, no problem. All right. So for what I show you here, basically the answer should be the stretch must be coming in front from the translation in the Y. So this is a proper sequence that you should show. All right. If you want to put them separately, then for this translation in X, you can put it anywhere. So that means if you want, you can put the first one is translation in X, followed by stretch in Y, then followed by translation in Y. Or maybe some students say that I prefer to start with stretch in Y, then followed by translation in X, followed by translation in Y. Also can. All right, if you don't want to combine both translation. So you can put the translation in X anywhere. But just make sure that in your answer, you have to show that stretch in Y always come in front, okay? And then translation in Y follow at the back. All right. So this is what we have for this question. All right. So there's another option that you can write an answer. So this is the first set of question. Sorry, first set of answer. Yeah. So for me, I'm doing it in this way. Okay. All right. Then for some students, they are not thinking in this way, but they think of some other kind of sequence. All right. So what the other option is, some students, they're thinking of Y can be written as 4 with a big bracket, then X minus 3 square minus 2. So they try to factorize the 4 from the whole function. Okay, all right. So now I will show you the possible answer for the for this. Okay, so that means it is the alternative solution. If let's say you are seeing it in this way, okay, so the alternative solution is you are changing y equals to x squared becomes something like this. This is the sequence. What's the proper sequence here? Okay, so originally you are having x squared, okay, and after that you make it become x minus 3 squared. That means it is a translation in x. Okay, and after that you minus the 2, which is the translation in y. Then follow again the next last step. So the last step is you multiply the 4 to the whole function. Okay, so if you have a look for the sequence here, it will be a bit different from what I showed you just now, right? By using the red color one. Okay, so for if you are rephrasing your answer like this, right? Okay, so if you have a look for the transformation, the sequence already changed a little bit. So you can have a look from here. x squared to this one is translation in x. You still having two translation of y, okay? So this is translation, sorry, transformation of y. So this is translation in y. This is stretch in y, okay? But if you have a look for what we have here, right, you need to remember that we have to settle everything inside the bracket first. Then only I multiply the 4 to the whole bracket. So if you are writing out your answer in this form, right, in this way, that means your translation in y have to come before the stretch in y. Okay, so the second set of answer will be something like this. You have to start with translation first. So you're having translation with the vector. For the x, you are moving it 3 units, say 3 units to the right, so it should be a positive 3. And then for the y is negative 2. Translation in x, then followed by translation in y, so the y is negative 2 only. Okay, after that only you are having the stretch. So the stretch factor is also a 4. Right? Yeah, so this is the second set of answer. If let's say you are not looking it in this color, this sequence, then you can factorize the 4 and then you have to transform the graph by using translation first, then only followed by the stretch in y. Right? So no matter which method you're using, both are correct. Just it is just on how you look at the final equation. So some students look at final equation like this, and some students they try to factorize out the 4. Both are correct actually. Right? So this is how we solve question number 3. They want us to show this equation so that it can be expressed as this type of equation. Okay, so now our final answer here is having all the sign. Okay, so our aim from the beginning of the equation is you have to try to change your trigo identity become everything with the sign. So let's start. Okay, so for the first step, I will want to change the tangent theta become sine over cos. Because tangent there's no sine, but if I make it become the fraction, right, it will be having sine over cos. So you are getting something related to sine here, okay? So 7 I just copy as 7, cos theta I copy as cos theta. So tangent theta means you can change it become sine over cos. Next, you want to get rid of the cos square. Okay, if you want to get rid of the cos square, you multiply the whole equation with cos square. So you're having 7 sine theta plus 12 cos square theta equals to 0. Okay, then again, in my final answer, there's no cos. So that means I have to change my cos square theta become sine. How can I change cos square theta become sine? So we are having the identity sine square theta plus cos square theta equals to 1. Therefore, cos square theta is equals to 1 minus sine square. So this is what I want to use here. So I replace it into my cos square. Rephrase the equation. Okay, so multiply a negative to the whole equation here. Okay, so this is how we get what they want us to prove. Alright, yeah, so let's continue to part B. For part B, they want us to solve this equation. So again, usually for part 1, right, when they ask us to prove something, usually for part B, you have to use the result that they ask us to show. Okay, so to solve this equation, you can directly solve it from here. Alright, so I'm not going to waste time. I directly copy the answer from this part first. Okay, and try to think how can I solve this equation. This is basically a quadratic form equation in terms of sine theta. So you try to factorize it. If you can't see clearly, right, you can let y equals to sine theta. then you will be having something like 12y squared minus 7y minus 12 equals to 0. Okay, all right. So this is a quadratic form equation, yeah? So for this quadratic form equation, if I try to factorize it, I should be having 3 sine, 3 sine and 4 sine here. And after that, for the 12, right, I want to get 7. 4 times 4 is 16. 4 times 4 and 3. This is 4, 3. Then should be negative 16. This is negative, then this is positive. Okay, all right. So we try to solve the equation from here. Sine theta equals to 4 over 3. Another equation is sine theta equals to negative 3 over 4. Alright, yeah, so let's solve the first equation. When you're having sine theta equals to 4 over 3, 4 over 3 means a value that's more than 1. It is equals to 1.33333, okay? So sine theta equals to 1.33333. If you take sine inverse for the basic angle, you realize that it is a math error. There's no solution when your sine theta is more than 1 or less than negative 1. Alright, so there's no solution for this part. Therefore, we can only solve this second equation here. Alright, so to solve this second equation, first step, I want to find the basic angle first. To find this basic angle, it is sine inverse. And basic angle, we always ignore the negative sign. So I'm having 3 over 4. Okay, in my answer here, the theta is between 0 to 360. Therefore, my answer should be in the unit of degree lah. So when you press calculator, sine inverse 3 over 4, try to get the value of degree correct to 1 decimal place, which is 48.6. Okay, so now I need to go through the quadrant and see which is the quadrant, which is the answer that I want from that particular quadrant. Okay, so I label it first now, all sine tangent cos. Then this is theta, 180 minus theta, 180 plus theta, 360 minus theta. Okay, then now I'm looking for the answer for my equation here. For this equation, I'm looking for sine with negative value. So in which quadrant sine is negative? First two quadrants sine is positive, so I don't want the answer from these two quadrants. For third quadrant sine is negative, therefore I will take 180 plus the basic angle, 48.6. Okay, so 180 plus the basic angle, 48.6, you'll get an answer 228.6. Okay, then after that, go to the fourth quadrant. Fourth quadrant also I'm having sine negative. I also want the answer from this quadrant. So you take 360 minus the basic angle 48.6. So from here you'll be getting 311.4. Okay, so we should stop here because for this question, right, they're only asking the data from 0 until 360. That means it is one quadrant. One cycle. That means 4 quadrants. So you already go through 4 quadrants, you can directly stop here. Right, so this shows that for this equation, we have two final answer, which is 228.6 and also 311.4. Yeah, so this is how we solve question number 3. Question number 4. We are given a function fx for x greater than 1. Find an expression for f inverse x. So to find the inverse function, usually I will let y equals to the original function. Then I want to replace it become x equals to something something y. So that will be my inverse function. Okay, so I will bring the plus 1 over, the negative 1 over become plus 1. Then the x here will become y plus 1 squared. Okay, so that means my inverse function will be equals to x plus 1 squared. So the variable y, I directly change it become x. Okay, so very easy. This is how we get the inverse function. Okay, then let's continue further to part B. For part B, we were given a diagram and they are telling us that this is the graph for gx. And gx is 1 over x squared plus 2 from negative to positive infinity. So state the range of g and explain whether g inverse exists or not. Okay, so to get the range of g, I want to know what is my highest value of the g, the function g. So this will be the highest value, right? Okay, so what is the value? What is this value? Okay, so to get this highest value here, I substitute 0 into my function g. So I'm having half. Okay, and you will realize that my graph for the function g is basically between the half and also the x-axis. Okay, at the two ends of negative infinity to positive infinity, the graph will getting closer and closer to the x-axis, but they will not touch the x-axis. That means the answer, the value here is getting closer and closer to 0. Therefore, this is the range for my function g. So if I want to write out properly, it will be range of g. It will be greater than 0, but it will not touch the 0, right? So y is greater than 0 without the equal sign. And after that, for the top part here, since I know that this is a value half, and it is included because the graph passed through the point half. Therefore, the range is smaller or equals to half. Okay, so to find the range for this case, you can use the diagram to help you. Alright, but of course, to know this highest value here, you need to substitute x equals to 0 to know this particular highest value for the y, right? Okay, so this is the range of g. And after that, they want us to explain whether g inverse exists or not. If you have a look for the diagram, you will see that basically g is not a one-to-one function. It is not a one-to-one function, therefore one-to-one function means that if you draw any horizontal line, there's only one intersection point. But you can, if I draw a horizontal line here, I got two intersection points. So this shows that function g is not a one-to-one function. Okay, so g has no inverse. So you have to tell them g has no inverse. Okay, because g is not a one-to-one function. The keyword is one-to-one. So you have to tell them clearly that it is not a one-to-one function. So that's the reason why this particular function g here, no inverse function. Okay, so let's continue to part C. Okay, so part C for this question. Now we are given another function which is h. And for this function h here, they define it as x greater equals to 0. Okay, they want us to solve this equation where h f x equals to f25 over 16. Then give your final answer in this form where a, b, and c are all integers. Okay, so we directly start from the equation that they give us. So hfx, this is a composite function of hf equals to f25 over 16. That means it should be a value, right? If I substitute the value of 25 over 16 into the function f. Okay, what is my function f? According to the first part, your function f is square root x minus 1. So that means I have to substitute square root x minus 1 into my h. Then for function f here, I want to substitute 25 over 16 into my x. So I'm having square root 25 over 16 minus 1. Okay, so next substitute x square root minus 1 inside the function hx, you will get this one. So square root x minus 1 square plus 2. That equals to, simplify this answer here, by right you have 1 over 4. Okay, so we have to continue solving this equation so that I can get the value of the x. Okay, so let's continue further. If I try to bring out the bracket, or maybe we cross multiply the bracket, you will get this equation eventually. X minus 1 square equals to 2. I want to take square root both sides to get rid of the square root. So I'm having, to get rid of the square. So I'm having plus minus square root 2. Okay, so continue further. Square root x equals to 1 plus square root 2 and also 1 minus square root 2. Okay, and to get the x, how can I get the x? I'll need to square both sides, where I have 1 plus square root 2 square and also 1 minus square root 2 square. Okay, so for the final answer that they want us to show is in this pattern, a plus b square root c. So I have to expand my answer here. 1 square is a 1, you have 2 square root 2. Square root 2 square is a 2. Same thing happen for the second answer. 1 is a 1 minus 2 square root 2, then plus a 2. End up, you will be having these two value here, 3 plus 2 square root 2, and also 3 minus 2 square root 2. Okay, so is this belongs to both of these answer belongs to my final answer? Okay, so when you're trying to solve the question like this, right, you have to be extra careful, especially they involve the function. Okay, so let's have a look for this function hfx. Okay, so for the function hfx, the function fx comes first, followed by function h, right? You put the function f into the function h. Therefore, the domain for this composite function, we are looking at the domain of the function f because function f start first. So you have to look for the domain. Okay, so domain of the function f. What is the domain for the function f in this case? It is x greater than 1. That means for all the value of x that you get, right, from the composite function, you have to make sure that it is x greater than 1. Okay, so double check your answer here. You got two answers in this case, right? Which answer give you the value larger than 1? So if you use the calculator, you realize that this value is 0.7 something only, which is less than 1. So you have to ignore this answer. And eventually, we have only one complete answer for this case, which is x equals to 3 plus 2 square root 2. Okay, so when we are solving the question that especially related to the function, we have to look at the domain defined very carefully. Okay, so every time we have two answers or more, please make sure that you double check which one is your correct answer. Then only write it out again in the last step. All right, yeah, so this is how we solve question number 5. We have the first and second term of arithmetic progression. It is given by tangent theta is the first term, sine theta is the second term. And the theta is defined from 0 until pi over 2 only. So given that theta is pi over 4, find the exact sum. Highlight the keyword exact. They want to have the sum of the 40 terms in the progression. Okay, so since I'm having first term as tangent theta, right? So now they put theta is pi over 4. So my first term is tangent pi over 4. Second term is sine pi over 4. If I put it into the value, tangent pi over 4 will be a 1. Sine pi over 4 will be sec 2 over 2. Okay, so I know that A is the 1. Okay, then for arithmetic progression, I want to know what is my common difference. So the common difference will be second term minus the first term. This is my D. And now I can directly calculate the sum of the first 40 terms here. So for the sum of the first 40 term, you are having the formula. So just recall back, yeah. If in case you have forget the formula, right, it is provided in the formula booklet. So we are having n over 2, then 2a plus n minus 1d. Okay, so as my n, in this case is 40. What's my a? A is a 1. Then plus n minus 1. N minus 1 now become 39. And then the d is 2 over 2 minus 1. Okay, so I simplify the number first. For the 39 here, you try to multiply into the bracket. Okay, so you'll be having 39 over 2 sub 2 minus 39. Okay, so further expand and simplify it. By right, you will have 390 square root 2 and then minus 740. So I want to keep my answer in this way because they are asking for the exact sum. So exact sum means that your final answer must be in surd form, pi form, exponential form, that cannot be in long decimal number. So I can see that, oh, this is the exact sum that I can have. All right. Okay, so this is the way that we solve question number 5, part A. So let's continue to 5, part B. For number 5, part B, now they are telling us that we are having a geometric progression. And first term, second term is given as tangent theta and sine theta. Then again, find the sum to infinity of the progression in the terms of theta. So in terms of theta. So for this question, they didn't tell us what's the value for theta, but we just need to find out the sum to infinity in terms of theta. Okay, so first of all, we need to find out the R first. What's the common ratio? This is a geometric progression. So I need to have a common ratio. Common ratio means that second term divided by the first term. So second term is sine theta divided by the first term is tangent. Okay, all right. So if I want, I can simplify this particular term here because sine theta is sine theta. Tangent theta, I can write become sine over cos. If I try to simplify it, you can see that my R basically is cos theta. Okay, all right. Then when we want to find the sum to infinity, what's the general formula for sum to infinity? So it is actually A divided by 1 minus R. Okay, so same thing happened here. I substitute inside. What is my A? A is the first term. In this case, our first term is tangent theta, so I just keep it as tangent theta divided by 1 minus R. So I take 1 minus cos theta. Okay, so for this question, right, they didn't tell us until which stage should we simplify our answer. They just tell us that our final answer should be in terms of theta. So I think this answer is good enough, okay, because my answer for sum to infinity is in terms of theta. That's it. Okay, so this is how we solve the B1. And now let's continue to B2. For B2, they give us the value for theta already, which is pi over 3. They want us to find sum of the first 10 terms of the progression if your answer correct to 3 significant figure. So again, now my first term is tangent theta. Okay, second term is sine theta. So if you have a look here, right, if I substitute my value inside, I'm having tangent pi over 3 and also sine pi over 3. If you convert into the value, tangent pi over 3 will give you sub 3. First term is sub 3. Then the second term is sine pi over 3. Sine 60 degree, you are having square root 3 over 2. Hey, sorry, did I substitute wrongly? Correct, right? Second term is sine. Okay, so sine theta, and then this one will be set 3 over 2. Okay, and just now, I know that this is my first term, A. Then this is my second term, T2. Okay, and just now we know that what is our R? Our R is cos theta, right? Okay, or you can take the term number 2 divided by term number 1. Also can, they are the same basically. So it's either cos theta or you can substitute sub 3 over 2 then divided by sub 3. Also correct. So you can see that your R is equals to half. This is your common ratio. Okay, I have the first term, I have the common ratio, therefore I can proceed with the sum of the first 10 term. Okay, so what's the general formula again for the sum of the first 10 term in a geometric progression? So it should be A 1 minus R power n divided by 1 minus R. Okay, so now I'm looking for S10. A is sub 3. 1 is 1. R is half power 10 divided by 1 minus R, which is 1 minus half. Okay, then maybe you just use calculator to help you a little bit to get the final answer. You'll be getting a long number. And now we cut it short, correct to 3 significant figure. Okay, yeah, so this is how we solve question number 5. Question number 6. There's a curve with this equation, has a minimum point at A, intersect the positive x-axis at B. Find the coordinate of A and also the B. Okay, so when they talk about minimum point, we have to link it with dy dx equals to 0 and solve the equation to get the x coordinate. Okay, then for intersection of positive x-axis at B, right, you have to let y equals to 0. Because at x-intercept, y should be equals to 0. Okay, so I will start with point B first. Okay, so I let y equals to 0. What will happen to my equation here? I'll be having 2x minus 8x power half equals to 0. From here, I can factorize out 2x square root or 2 square root x. If I factorize out the 2 square root x, then what do I have here is I still have x square root x, then minus 4 equals to 0. Okay, then I try to solve it. So when I try to solve it, right, 2 square root x equals to 0, your x will be equals to 0. This is the answer I want to ignore because they're asking us to find the b, which is cutting the positive x-axis. So I will consider only this equation. Square root x equals to 4. And therefore, your x is equals to 16. This also tells you that the coordinate for the b here is basically 16 and 0. Okay, then continue with the point A. For point A, we need to find out dy dx first and let it equals to 0. So I'm having y equals to 2x minus 8x power half. How to find out the dy dx? Differentiate 2x, you will get a 2. Differentiate negative square root x, copy the constant negative 8. Power, you put in front, copy the x, power minus 1, which is negative half. And then you need to let dy dx equals to 0 because at stationary point, minimum or maximum point, the dy dx is always equals to 0. So you try to solve your equation from here. Okay, so continue solving this equation. You'll be having sub x equals to 2. And therefore, your x is equals to 4 when you square it. When x equals to 4, I want to get the y. So substitute 4 into your original equation of y. Okay, then you get your value negative 8. This also tells you that A having the coordinate of 4 with negative 8. Okay, so let's continue to part B. For part B, they give us a diagram. And now they tell us that, oh, okay, we are having the curve, we are having a point AB with the line AB, and they have give us the line, the equation for the line AB, which is this one. So now they want us to find the area of the shaded region between the curve and also the line. When you want to find the area bounded by the curve and the line, what we use is like we have to use the integration. Okay, so the integration. The limit for the integration will be the intersection point of the curve and also the line. So the intersection point, I got it already. I got the coordinate for A just now. I also got the coordinate for the B just now. Okay, and when the area is bounded by the curve and also the line, then basically you have to take integration of the curve minus the line. Okay, or you can take the line minus the curve. But if let's say if you have a look for this diagram here, right, curve is having a larger area, then line is having a smaller area. So by right, it should be curve minus the line equation. Okay, and the limit is the coordinate for the A and also the B. Okay, so just to recall back again, what is the coordinate of A that we get? The x coordinate for the A that we get is value 4, right? And the B that we get is basically 16. So if I want to find out the area, when I set up the question, it should be something like this. Okay, integrate from 4 until 16, the equation of the curve, which is 2x minus 8x power half, minus the line equation, which is 2x minus 32 over 3. But if you observe carefully from the diagram, right, the area that we find out here, when we integrate it, this is the whole thing below the x-axis. When you're having the area below the x-axis, when we integrate it, we'll have a negative value in general. So to change it become positive, right, we need to maybe multiply a negative in front of the whole equation. That means if I carry out the integration here later, I will straight away get a negative value. So you multiply a negative value to make it become positive because our area should be a positive area. Okay? Yeah, so after you write out the equation correctly, then you can start the integration very slowly and very carefully. Okay, so for me, if I don't want to do careless mistake, what am I going to do now is I try to expand what do I have first. Negative, maybe I directly multiply in, so I'm having negative 2x, then negative 8x, positive 8x power half, then positive 2 over 3x, okay, then minus 32 over 3. Okay, so after I'm making clear everything here, then I try to integrate them. Integrate negative 2x squared, integrate x, we have x squared, then divided by the new power 2. Integrate this one, you'll be having power 1 plus 1, which is 3 over 2, divided by the new power. Integrate this thing, you're having 2x squared divided by original 3, then divided by a new power 2. Then 32 over 3, integration will give you x, 32 over 3x. Okay, then after that, I need to put in the limit 16 and also the 4. Again, before I integrate or before I substitute the limit, I prefer to simplify all the terms as much as possible first. So 16 over 3, x power 3 over 2. Then this one will be 1 over 3 x squared. This one will be 32 over 3x. Okay, so observe the equation again. Negative x squared plus 1 over 3x squared will give you negative 2 over 3x squared. Okay, then plus 16 over 3 x power 3 over 2 minus 32 over 3x. Then 16 and also 4. Okay, so I feel that I cannot simplify the expression more already. Then I will directly substitute the value inside. Okay, so substitute 16 here. You'll be having negative 512 over 3. Okay, substitute 16 into this one. So square root 16 means 4. 4 power 3 times 16 divided by 3, you'll be having 1024 over 3. Substitute 16 into this particular term here, you will have negative 512 over 3. Okay, done substituting the first value. Now I want to substitute the second value, substitute 4. If I substitute 4, the first value that I get is 16 times 2. It will be 32 over 3. Then second value is square root 4 is 2. 2 power 3 is 8. 8 times 16 divided by 3. So you get 128 over 3. Then for the third term, if you substitute it, you are having 4 times 32 is 128. So 128 over 3. Okay, then after that, you simplify the answer. If you can observe very carefully, right, all the first term here cancel off with each other, they become 0. The last two terms here cancel with each other, they also get a 0. So I only left this particular term here, which is 32 over 3. Okay, so you can see that after I multiply a negative before my integration, right, only I'll get a positive area. If not, you'll get a negative area. If you get a negative area, then you directly make it, make a modulus with it and change it become positive also can. Alright, but for me, I already adjust it to positive value at the beginning before the integration. Okay, so this is how we solve question number 6. Okay, so question number 7. We are given a circle equation, and after that they say that we have an equation, linear equation, yeah, and it is a tangent to the curve or tangent to the circle. So find the two possible values of a constant A. Alright, so first of all, when they are talking about a circle and we have a linear line where it is a tangent of the circle, so tangent means that the line will pass through the circle at one single point. So we are going to use the concept of b squared minus 4ac equals to 0. If I try to substitute the linear equation into the curve equation, okay, so this is what we can do for this question. Right, so let us start. So our equation of linear is y equals to 2a minus x. And I want to substitute it into the circle equation. Okay, so it will become x minus 6 squared plus y. Y is 2a minus x plus a squared equals to 18. And after that, you can try to expand the whole thing. Okay, so maybe for 2a plus a is 3a lah. So 3a minus x squared equals to 18. And from there, we start to expand everything here. Okay, so after you expand, you'll see that in your equation, you have something with x squared and everything. And 2, to use it as b squared minus 4ac equals to 0 later, I will need to rephrase my answer or my equation here into the quadratic form equation. So I'm having 2x squared, then plus b. B is negative 6a minus 12x. And then c, bring the 18 over, so you're having 18 plus 9a squared. Okay, and because we want to use the b squared minus 4ac equals to 0 now, after I get the quadratic form equation, right? Then I'm using this because of, again, our line is actually a tangent to the circle, and they only cut each other at one point. Okay, so we are using b squared minus 4ac equals to 0. What is a b squared here? Negative 6a minus 12x, oh sorry, minus 12 squared minus 4ac. Okay, so simplify from this part. Of course, you still need to expand everything lah. So expanding, I'm having 36a squared. Okay, then plus 144a plus 144. So just try to expand everything. Okay, then if I simplify this equation, I'll be having negative 36a squared plus 144a. I further factorize out the negative 36a, then I will have a minus 4 equals to 0. And therefore, a is having two values here, where a equals to 0 and also a equals to 4. Yeah, so this is the two value of a, because here they did tell you that find the two possible values of a constant a. So the 0 shouldn't be ignored. Okay, so you have to keep two value here as the answer. Alright, then let's continue to part B. For part B, for the greater value of a, find the equation of the diameter which is perpendicular to the given tangent. Okay, so we get our answer from part A, yeah? So from part A, I know that the greater value of A, right, is actually 4. Okay, therefore, the tangent line in part A also, if I try to substitute A equals to negative 4 into the equation, right? So your tangent line basically is y minus 4 times 2 is 8 minus x. Okay, or you can write become y equals to negative x plus 8. So from here, you actually know that the gradient of the tangent is equals to negative 1. So the gradient of tangent for this tangent line is basically a -1 because you have negative x, right? So y equals to mx plus c, therefore the m is -1. And why do I need to have this gradient of tangent? It is because of later I want to form the equation which is perpendicular to the tangent. So to find the gradient for perpendicular line, I need to use this and get the gradient later, right? So let's start. Since I know that the perpendicular line and the tangent, they are perpendicular to each other, therefore the gradient of perpendicular line multiplied with the tangent, what's the value that we should get? We should get it equals to -1. So from here, the gradient of perpendicular line will be what? -1 divided by the gradient of tangent, which is also -1. So eventually you get a 1 here. Okay? Yeah. So you get a gradient already. And now I want to know what's the passing point. Okay, so like what I told you just now, we are having a circle, right? And then we basically have a line with the tangent. So I want to form the perpendicular line, which is this one, 90 degree. Okay, so I want to get to know what is this midpoint here. Oh, sorry, what is this particular point here? How can I get this particular point? Again, you go back to our first part and looking for this equation. Looking for this equation. So if I have my a equals to 4, then for this equation, I can solve for the x. All right, and that will be the point where I form a tangent with the circle. Okay, so I will substitute a into the equation. If I substitute a into the equation, right, I'm having 2x squared minus 36x plus 162 equals to 0. Okay, so I rewrite again. From part A, this is the equation I get. From part A, I get 2x squared plus -6a minus 12x plus 18 plus 9a squared. Okay, since I know that my a is equals to 4, right? So if I substitute 4 into this equation, so this is what I can get. So why do I want to get this equation? Because I want to get a coordinate of x where it formed the tangent with the circle. Right? So simplify this equation. And you realize that your x should be equals to 9 after you factorize it. Okay, so to form the perpendicular line equation, you need the coordinate, the passing point. I have the x equals to 9. I also need to know the y. So what is the y that I have here? So the point passed through the tangent line. Okay, so to calculate the y, I can substitute x into the equation y, which is -x plus 8. So -x plus 8, you are having -1. Okay, so your coordinate of the point that form tangent with the circle is 9 and -1. And now I want to form the perpendicular bisector that pass through this point and also with the gradient 1. Okay, some students will say that the question said perpendicular that pass through the diameter. Basically, if you are aware, no matter where is your tangent, right? If you draw and try to draw a line of the perpendicular, it will definitely pass through the circle one. It will definitely pass through the center. Okay, and form the diameter, right? Okay, so I have this point, I have this gradient, therefore I can get the equation of perpendicular line. So what is the formula that we use to form the equation? So I'm using y minus y1. So y minus y1 is -1 equals to gradient. Gradient is 1. Then x minus x1. Okay, so if you try to simplify this equation here, by right you will be having y equals to -10. Alright, so this is how we get the answer for question number 7. Question number 8. There's a diagram, show a symmetrical plate. So highlight the keyword symmetrical. Okay, so ABCD is the straight line. Then the length AB is 2. Each of the two sectors of ABF and DCE is radius r. And then the angle of ABF and DCE is equal to pi over 3. Okay, given that r equals to 0.4, show that the length of EF is equals to 2.4. Okay, so before I can show the length of EF, what I want to do is like I want to draw a vertical line from B to the line EF. And I want to form a triangle here. Okay, so for this particular point here, I will label it as B prime. Okay, and I have to make sure that this is 90 degrees. It is a straight line. Okay, now, then before I can get EF, right, I want to get this length first, the length for FB prime. If I get the length here, this length of C prime E also same as FB prime. Okay, so this I label as C prime. Okay, so these two lengths here in the red color part is basically the same. So after I get the length for these two, only I add it together with the 2 to get the total length of EF. So this is what I plan to do lah. Okay, so if I have a look for this triangle, right, 90 degree, for a straight line it is 90 perpendicular line it is 90 degree. And if I have this as pi over 3, so very obvious, this particular angle here will be pi over 6, which is 30 degree. So I'm going to use the ratio, okay? I'm going to use the ratio for the triangle in this triangle, yeah? Okay, I know that the hypotenuse here is actually 0.4 because it is a radius. Okay, r equals to 0.4. So 0.4 is the hypotenuse for this triangle. And to calculate the length of FB prime, I'm going to use sine, the ratio of sine. Okay, so from the triangle here, you can see that sine pi over 3 can be written as FB prime over 0.4. So what's the length for FB prime? So FB prime equals to 0.4 multiplied with sine pi over 3. What's the value for sine pi over 3? It is the half. Okay, therefore you are getting 0.2. And also this is equals to the length of the primes C prime E. Therefore, you can get the length for EF now. So to get the length for EF, you have 0.2 times 2. 2 times, right? And plus the length, okay, between B prime and C prime. B prime and C prime basically is having the same length as B and C, which is a 2 also. So if you add them together, you can prove here that EF equals to 2.4 cm. Okay, so this is how we prove this question. And let's continue to part number 2. Find the area of the plate. Give your answer correct to 3 significant figures. Okay, so to find the area, there are a few ways that you can do it. So for me, right, basically what I do is like I separate into 3 parts here. First part is 2 times of the sector. Second part is 2 times of the triangle. And the third one is the single rectangle here. Okay, so sector times 2, triangle times 2, then plus the rectangle area. So this is what we plan to do for this question. Okay, so let's start. Okay, area. So area is 2 times of sector plus 2 times of triangle plus the rectangle. Okay, so what's the area for the 2 sector? So the sector here is half r square theta. So what is the r square again? The r square here, the r is given 0.4, right? So you're having 0.4 square, and the theta is pi over 3. This is the area of sector. Then plus 2 times area of triangle. The area of triangle, I want to use base times height, half. Okay, half base times height. So I'm having half. What is the base? So the base here is FB prime. FB prime, just now you already get the value, which is 0.2. So this is a base. And what is the height? So to calculate the height, I take the square root of hypotenuse square, 0.4 square, minus the base square. So this is my height. Okay, then plus the rectangle area. So what's the rectangle area again? It is 2 times the height also, right? So I take the 2, which is the base, multiply with the height. So again, the height is like what we have just now in the triangle. It is 0.4 square minus 0.2 square, then square root. Okay, so please take note, this is a multiply 2, not square root, yeah? Okay, then you just try to simplify the answer for this part. For me, I got 4 pi over 75, and then I got 0.2 square root 3 over 25, where this one is 2 square root 3 over 25. Okay, then from here, I will get the answer which is 0.930. Correct to 3 significant figure. Okay, then let's continue to part B. Okay, so now let's come to part number B. It is given that the perimeter is 6 cm. Okay, find the value of R, give your answer correct to 3 significant figure. Alright, so perimeter is 6. Can I get the perimeter here? According to the diagram that I draw just now, right, that is provided on top just now, I want to take 2 times of BC plus 2 times of AB, which is the radius. Okay, because AB and CD are the same. So both of them are radius. So I take 2 times of AB, 2 times of the arc AF, because both arc is having the same length, right? They are symmetrical. And after that, 2 times of FB prime. And it is equals to 6. Okay, so what is the value for BC? BC is given 2, so you just put it as 2. What is the value for AB? You don't know, so you put it as R because it is the radius, right? Find the value of R, so it is radius, so I just put it as R. What is the arc of AF? So again, you don't know the radius, so you just put it as R. Then the arc of AF should be R theta. So R theta, you know the value, which is pi over 3. And then 2 times of FB prime. Okay, so for FB prime, just now we know that sine pi over 6 equals to FB prime over R. Therefore, your FB prime should be equals to R and then sine pi over 6. And I cannot substitute the R with 0.4, yeah, because now I don't know the R and I want to find the R now. Okay, so I put it as R, then sine pi over 6, which is equals to 6. Okay, so try to simplify them. Sine pi over 6 is basically half, half times 2, you get an R, then equals to 6. Okay, so from here, what I try to do is like I group all the R together and factorize out the R. Therefore, I bring it over, become 6 minus 4, I get a 2. So R divided by this bracket here, you'll get a long answer. And R equals to 0.393. Okay, so this is how we solve this question number 8. Question number 9. There's a function f and they give us the function of f prime x. So f prime x equals to this whole thing. And then they want us to determine the set of value x when the fx is decreasing. Okay, so when they are telling us about fs decreasing, means that the function f is getting smaller and smaller, right? When the graph getting smaller and smaller or decreasing, basically you can see that all the tangent line also decreasing. So if you try to link decreasing function with the gradient of tangent, right? So that means that the gradient of tangent should be negative. Okay, or you can write as dy dx smaller than 0 because it should be negative. The gradient of tangent should be negative value. Okay, so we are going to use this concept to solve and get the set value of x. Okay, so let's start. I'm starting from this part, f prime x smaller than 0. So what's my f prime x here? So I'm having 6, 2x minus 3 square minus 6x smaller than 0. Okay, so expand it. Okay, then if I try to further simplify everything here, right, eventually you will get equation inequality 24x squared, then minus 78x plus 54. Then smaller than 0. So try to factorize it. Try to simplify first because the number is quite big. If I try to simplify it, I will get 4, then minus 13x, then plus 9, smaller than 0. Okay, then after that, I can try to factorize them. So if I try to factorize them, what do I have here is I'm having 4x, then an x here, then I want to have 13. So 9 times 1 and 4. Negative 13, so minus and minus. Okay, what's my critical value here? To determine the inequality answer, yeah, you cannot directly just solve them in this way. So maybe need to draw a number line or maybe the graph to help you a little bit. So I try to get the critical value first. You assume that 4x minus 9 equals to 0, therefore your value of x is 9 over 4. X minus 1 equals to 0, therefore your value of x is a 1. And after that, I want to draw a number line from this part. So 1 is smaller, right? 9 over 4 is larger. Therefore, I draw two lines to make the bracket become positive one. Okay, of course, if you want, you can draw a U shape for yourself lah. And then we are looking for the negative part, right? So positive, positive is positive. Positive, negative is negative. Negative, negative is positive. So in my answer here, I'm looking for dy dx smaller than 0. So I'm looking for the negative part. So the negative part is this one, which means that your x should located between 1 until 9 over 4 to get the f prime x smaller than 0. Okay, so basically this is how we solve the 9a. Alright, so let's continue to 9b. For 9b, they are telling us that f1 equals to negative 1, find the function fx. Okay, so what should we use now? What is the technique that should we use here? Okay, so basically, if I want to get fx from f prime x, I have to apply integration. Okay, right. So to get function fx, I need to integrate my f prime x. So what is my f prime x function here? My f prime x function is 6 and then 2x minus 3 square minus 6x. So they will ask, can we just use back the expanded equation for the integration? So some students would want to use this one. After they expand, they get this one, right? Yeah, you can use the expanded answer, but you cannot use the equation that's after simplified one, cannot. You have to use the original expand answer to integrate. If you want to use the expanded equation, for me, I just use back the original equation from the question. So both will give you the same answer basically. All right. Okay, so I start the integration now. 6 is a constant, I just copy. I copy the bracket first, power plus 1 become a 3. So I have to divide it by the new power. Besides, I also need to differentiate the thing inside the bracket. Differentiate 2x minus 3, I get a 2, right? So I have to divide by 2. Then copy the negative, copy the 6, it is a constant, integrate x power 1. So after the integration, your power plus 1 become a 2, then you have to divide it by a new power. After you integrate both terms here, don't forget about the constant term at the end. Then if you try to simplify it, what do we have here is 2x minus 3 power 3 minus 3x squared and then plus c. This is your function fx. Okay, and now we are given the value where f1 equals to 1, equals to negative 1. That means you have to substitute 1 into your equation and you equate it to negative 1. Okay, so what's the value for f1 that I will get? What do I have for f1? So substitute x here, become a 1. So what do we have here is 2 times 1 minus 3 cubed minus 3 1 square plus c equals to negative 1. Simplify your answer here. This one is negative 1, this one is negative 3, then plus c equals to negative 1. So simplify it, you'll get your c equals to 3. Then I just need to rewrite my final answer again. So what's my final answer for the function fx? Include the value of c. So you're having 2x minus 3 cubed minus 3x squared plus 3. Alright, So this is how we solve question number 9. Okay, so question number 10. The equation of the curve is this one, is given like this, and then the x is defined as smaller than 5/2. There's a point moving along the curve in such a way that the y-coordinate of p is decreasing at 5 minutes per second. So y-coordinate decreasing than 5. So basically when they are talking about the rate of increase or the rate of decrease, it is the rate of change question. So from this sentence, right, the rate of change for the y-coordinate, it will be dy, over the time, it will be dt. And the word decreasing, when you want to express the meaning of decrease, you have to put a negative in front, and then 5 units per second means -5. Okay, and now they want to find the rate where the x-coordinate of p is increasing when y equals to 32. So again, rate of the x-coordinate, which means that they want us to find out the rate for dx over dt. And they already give us a hint here where it should be a positive value, like because increasing, and now you should get a positive value. All right, then y equals to 32. So these are all the information that we have. Okay, so first of all, we need to have dy dx first. Why? It is because of, if I want to get dx dt, okay, I can't get dx dt directly from anywhere from here, but I realize that I can get dx over something multiplied with something over dt. I have to use the chain rule to get the dx dt. Then what's the something that I should put here? So the something that I can put here is I can refer to this one, because in this question they already provide us with dy dt. So that means the equation that we are using here in the chain rule is dx over dy multiplied with dy over dt. Okay, so first of all, how can I get dy dx? I can get dy dx from here first, from the equation. Okay, if I differentiate this equation, I will have dy dx. Then later, when I want to substitute into my chain rule, I will just need to flip them upside down. Okay, right. So how can I differentiate the y equation? So you're having a bracket with the power outside. Bring the power in front. Copy the bracket. Power minus 1 become half. After that, you need to differentiate the thing inside the bracket. So differentiate 5 minus 2x, you get -2, right? So I have to multiply with -2. Okay, then for the 5 is a constant here. So when you differentiate a constant, you'll get a 0. Okay, then if you try to simplify, what do you have here is you'll get -3, and then 5 minus 2x power half. Okay, then from here, right, I want to know what is the value of dy dx when y equals to 32. Okay, so again, now we need to let y equals 32. So given y is 32, what happened to my equation? So I'm having 32 equals to 5 minus 2x power 3 over 2 plus 5. Okay, so 5 minus 2x power 3 over 2 will be equals to 27. Then I have to get rid of the power 3 over 2, right? So when you want to bring it over, it will become power 2 over 3. Okay, so that means you take the cube root of 27, then you get a 3. 3 square, you get a 9. So 2x will be equals to 5 over the 5 minus 9, which is -4. And the value of x will be -2. Okay, then when you get x equals to -2, substitute it into my dy dx again. Okay, so that means at this particular instant, right, my dy dx value is basically -3 and then 5 minus 2 times -2 power half. So 5 plus 4 is a 9. So square root 9 is a 3. So -3 times 3 is a -9. Okay, then we rephrase, what do I have here again? Okay, so what do I have here is I'm having x equals to -2. Okay, then y equals to 32. Then the dy dx is -9. Then dy dt is -5. Okay, so to get the value of dx dt, I have to apply the formula dx over dy multiply with dy over dt, right? Okay, so what's the value for dx dy? So dy dx is -9. Therefore, dx dy is like you make the numerator become the denominator where you're having 1 over -9. Multiply with the dy dt. So dy dt was provided just now, which is -5. So to simplify them, you're having 5 over 9. Then don't forget about units, it will be units per second. Okay, so double check with this answer, you get a positive value. That means your answer very likely will be correct because of in the question itself, just now they did mention that the rate of change for the x is increasing. Increasing means you should have a positive value. Okay, and now we are having a positive value here. Okay, so this is how we solve the part A for question number 10. Let's continue to part B. Okay, so for part B, they said the point A on the curve has y coordinate of 32. So again, if you refer back just now, right, they did mention about y equals to 32, right? So when y equals to 32, your x is -2. So from here, basically you already know that your A is having the coordinate of -2 and also 32. Okay, then after that for point B. Point B on the curve is such that the gradient of the curve at B is -3. Gradient of the curve means dy dx. So for this sentence, you actually know the value that the idea that dy dx is equals to -3. So at this particular point, we label it as B. They want us to find the equation of the perpendicular bisector of AB. Give your answer in the form of this, where all these values are integers for A, B, and C. Okay, I have the coordinate for A. To get perpendicular bisector of AB, I need point B first. So how can I get point B? I have to start from here. dy dx equals to -3. Okay, so let us start, yeah? So let us find out dy dx equals -3, and what do I get for the x coordinate for the B? This is my dy dx equals -3. From part A just now, I know that my dy dx is -3, and then 5 minus 2x power half. This is my dy dx, right? So we let it equals -3. From here, you'll get a 1. So when you take square both sides, you also got a 1. So your 2x equals to 4 and your x equals to 2. Okay, when your x equals to 2, what happened to your y? Then again, I have to substitute it into my y equation. So the y equation that I get, right, basically is 5 minus 2x. So 2 times 2 is a 4, right? Okay, then power 3 over 2 plus 5. So you're having 1 plus 5 where y equals to 6. And from here, you know that your coordinate B is actually 2 and also 6. All right. So now, I'm having B is 2, 6, and then A is -2 and 32. So if you try to observe what they want us to find, so let's say I'm having this point A and this point B, they want us to find the perpendicular bisector where it will pass through the midpoint of AB, and then it is 90 degrees to the line of AB. Okay, so to form the equation, I need the midpoint of AB. I also need the gradient of AB. Okay, so let us start with midpoint first. What is the midpoint of AB here? Okay, so you take x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Okay, so you get 0 and 19. Alright, then after that, I want to get the gradient of AB. So you take y1 minus y2 divided by x1 minus x2. So from here, you get negative 13 over 2 after you simplify. Then, because I know that the perpendicular line, okay, when you take the gradient of a perpendicular line, multiply with the gradient of AB, it will be equals to -1. And therefore, the gradient of perpendicular line will be equals to -1 divided by the gradient of AB, which is -13/2. After you simplify, you have 2 over 13. Okay, so to form the linear equation, right, I need two information. I need the passing point, which is the midpoint of AB. I need the gradient of the line, which is this one. Okay, so since I have every details that I need, so I can start to form the perpendicular equation. Perpendicular bisector equation. Okay, so y minus y1 equals to m x minus x1. Okay, so you'll be having y minus 19 equals to 2 over 13x. Okay, so to put it into the general form, you multiply the whole equation by 13 first. 19 multiplied with 13, you're having 247 equals to 2x. Then you try to move everything to the other side. So this is how you get a general form for this perpendicular bisector equation. Alright, yeah, so this is how we solve question number 10. And this is the last question for this video, and thank you very much for watching the video.